Hi, today we are going to talk about inverse functions. I'll give a short introduction, and then we are going to have examples of how to find f inverse. Next, we are going to talk about graph of f versus f inverse. Then we are going to take a look at domain, range, and slope of a function f versus its inverse function f inverse. Topic number 5 will be existence of f inverse and a little lemma called the horizontal line test. And then we are going to take a look at situation where a function does not have an inverse and the remedy for that, which is titled restricted functions. Let's go ahead and take a look at some very simple examples of inverse functions. Simplest situation that you see this arising is when you are measuring a quantity and you want to use two different units and you want to change your measurement from one unit to another one. Suppose you have measured the length of something in feet, and then you want to convert it to inches. How do you do that? You take your measurement for feet and you multiply by 12. If you have measured in inches and then you want to convert back to feet, you have to take your measurement and divide it by 12. These two operations are reverse of each other or opposite of each other, and that constitutes the simplest example we could give for inverse function. To look at something somewhat more sophisticated, let's take a look at measuring temperature in Fahrenheit and in Celsius degrees and trying to convert from one to another. If you measure the temperature of an object and show it by F in Fahrenheit degrees and you want to convert to Celsius, you're supposed to subtract 32 from this and then multiply that by 5/9 to get the centigrade temperature reading. Now suppose you want to convert this from C to F. What do? I multiply both sides of this equation by 9/5, so we'll have 9/5 of C is equal to F minus 32, and then I move 32 to this side, so I'll get this equation F is equal to 9/5 of C plus 32. If you look at these two relationships, they constitute a pair of inverse functions. You can go from F to C or you can go from C to F, and that will be an interesting example. Now in mathematics you come across many operations that you can reverse. For example, if you take x and change it to 2x, the inverse of this operation or the inverse function is going to be taking x and dividing it by 2. These two make a pair of inverse functions. How about taking a quantity x and adding 3 from it to it? What is the inverse of this operation? Inverse of this operation to subtract 3 from it. Again, these are a pair of inverse function. Let's look at something a bit more complicated. Suppose I take a x and make x cubed out of it. What would be the inverse of that? Inverse of finding third power of an input would be taking the third root of the input. Now you might have seen some other examples somewhat more complicated. If you have a function x and I make 2 to the power of x out of it, the inverse operation is taking x and finding logarithm of x in base 2. If you haven't seen the logarithm yet or you don't remember, don't worry, come back to it again. Let me just give some other example. X, if you find exponential of x, then the inverse of that would be finding a logarithm of x. These are again a pair. If from x you make a sine of x, provided that you restrict your x to a range either minus pi over 2 radians to pi over 2 radians, or from minus 90 degrees to 90 degrees, then the inverse of that is written as x going to arc sine of x, sometimes written as sine inverse of x in this fashion. Let's go ahead and take a look at one numerical example for inverse functions. Suppose I take a, let's go to another page. Suppose I take a function y is equal to f of x is equal to 2x plus 3. Let's analyze this function. I can make a table for it. In this table I'll have a row for x's and another row for y's. I can choose for my x's simple numbers 0, 1, 2, 3, minus 1 and so on. For y I'm going to find 3. When x is 1 this will 5, 7 and 9. For minus 1 I'll have just 1. Now I might ask, if an output is given for me, if y is given such as number 101, and I want to find out what x was responsible for that y, what would I do? Well, look at the pattern here, or look at this equation, try to undo that. How can I undo this thing? Well, remove this 3 that is added. That's going to, if you start at 101, removing a 3 gives you 98, and then undo this factor of 2. 98 divided by 2 is going to make it 49 for you. So what did we do? Took 101, undid the addition of 3 by subtracting 3, undid the multiplication by 2, division by 2, and we got 49 out of this operation. Well, let's do that in general to some input that is given to me. Suppose I am given a y value, a general y. What do? I take that y, subtract 3 from it, and divide by 2. That's the equation that, given a y, tells me what to do to get the x. That's the opposite of the function that was given. The function was given as x, and we would go and find 2x plus 3 out of it, and that was the direction of calculation, was from x to y. We have reversed that operation. Well, we have a formal way of writing this. F is a function that starts at x and ends at 2x plus 3. This other operation starts at y and goes to y minus 2 divided by 3. This is called the inverse function. It's shown with the letter f, and we put a minus 1 on top of that to refer to the inverse operation. Let's go and take a look at some more complicated examples. Suppose I'm given a function. Here's my function. Y is equal to, let's call this one, say, r of x, for some rational function x, is equal to 2x plus 3 over, say, 5x plus 7. Question: find R inverse. How do we do that? Well, the idea is to find x in terms of y. If we can manage to do that, we have found our inverse. Well, each of these problems has its own approach. Essentially, you have an equation, you have to find a way that is applicable in that case to turn that equation around. Here, what we can do is to cross multiply, so I'll have y times 5x plus 7 is equal to 2x plus 3. I open this equation, I get 5xy plus 7y is equal to 2x plus 3. Next, I bring all the x's to one side. 5xy minus 2x is equal to minus 7y plus 3. I factor the x. 5y minus 2, right hand side still minus 7y plus 3. Finally, I get my x. In terms of y, I have x is equal to minus 7y plus 3 divided by 5y minus 2. Let's box our answers so that we can compare. This is x we found, and this is where we started. So the trick in this case was to cross multiply and solve. Look at how the answers look like. This is not accidental. You see here the numbers here are 2, 3, 5, 7. As you look at it here, 3 and 5 staying in their places. 2 and 7 have exchanged their location, and both of them became negative. It always turns out like that in these type of problems. Let's go ahead and take a look at another example. Let me choose my pen, and here we go. Next example. Let's say I have y is equal to function f of x equal to, say, x cubed plus 5. Again, question is find f inverse. Well, the steps in this case are easier. I can move the 5 to this side, and that's going to give me x cubed. Next, I take cube root from both sides. So I'll have x is equal to cube root of 5 minus, excuse me, let me correct this. This was this was y minus 5. And these are just going to be the inverse function. How do we write this inverse function? Let's go ahead and write it. I use a name same as the name of the original function. It was called, this will be f also. F inverse of, now I have to choose an input. Simply for the fact that sometimes we want to compare our inverse to the original function, we use the letter x here so that both of them can be compared on the same footing. So if I use x here, I'll be using x in this spot. I'll have cube root of x minus 5, and that whole output is going to be called y. So what happened here, at the end of this algebra that we have done and found the equation, we go ahead one more round, we exchange x and y. Instead of x we wrote y, instead of y we wrote x, so that later on we can compare this function against the original one we had. I forgot to mention same thing here. I had r was the name of the original function, so r inverse of x right hand side I'll have minus 7. I write x instead of y. Minus 7x plus 3 over 5x minus 2. That would be the inverse function R inverse. Let's go ahead and take a look at the issue of graphs. So here we are done with this examples. We are going to compare the graph of a function versus its inverse. Graph of f versus f inverse. Major news here is that these two graphs are related to each other in a very simple way. Let's take an example that's not going to be overwhelming. We just pick, say, y is equal to 2x minus 1. The inverse of this, by now you have learned how to find the inverse. Go ahead and find the inverse of this function. You will find out that it is x plus 1 divided by 2. Now we want to go ahead and graph both of these two functions. Let me go ahead and graph this. So this is our x. Let's make a table to make our life easier. Let me also label my functions. Call this one f and call this one f inverse. So for the function f, if I have my x's chosen as, say, 0, 1, 2, 3, and so on, y turns out to be, well, when x is 0, y is minus 1. When x is 1, this is 1. X is 2, 3, and this becomes 5. What if I want to get some numbers for f inverse? Well, really, the same set of numbers will do, except that now this is going to play the role of y for me, and this is played with x. This is for the function f inverse. In f inverse, if I put x equal to 5, if I put 5 here, 5 plus 1 divided by 2 is 3. So when x is 5, y is 3. When x is 3 here, y is 2, and so on. So x and y of f inverse are just same as x and y of the f, except that the roles have been exchanged. And that is the key to see how these two graphs relate to each other. Let's go ahead and graph f. At 0, I was supposed to be at minus 1. Let me use red for this one, so this is going to be in red color. When x was 0, this was minus 1. At 1, this was 1. At 2, this was 3. At 3, it was 5. You can guess how it goes. 4 will be 7. At minus 1, it will be minus 3, minus 2, minus 5, and so on. Let's go ahead and graph the other one in, say, green. Well, this one, when x is minus 1, y will become 0. When x is 1, y also becomes 1. When x is 3, y becomes 2. When x is 5, y becomes 3. When x is 7, y becomes 4, and so on. When x is minus 1 was 0, at minus 3 it's going to be minus 1, minus 5 is going to be minus 2, so on. Let's go ahead and write some of these coordinates just to emphasize the fact we just mentioned. For example, this is the point with coordinate 5 and 3 in the green function, and Corresponding to that is the point 3 and 5 in the red function. These 2 points, we refer to them as corresponding points. You see that their coordinates are the same except that they have been exchanged. Well, the graph of the red one and the green one are really reflections of each other in the 45-degree line. So let me draw the line exactly halfway between x and y coordinates. This is the line which is given by the equation x equal to y, and this angle is 45 degrees, so the line is referred to as the 45-degree line. So what did we learn here? Graph of f and f inverse are reflections of each other in the 45-degree line. Let me write that. Graph of f and f inverse are reflections of each other in the 45-degree line, which has equation y equal to x. Now let's go to the next page, or perhaps before we go there, another fact to pay attention to is the issue of, well, let's go to the next page here. Let's draw a very simple example of a function and its inverse. Suppose I have a function that simply consists of this line segment from here to here. What's the inverse of that? Well, we'll say you have to take the reflection in the 45-degree line, and when you do that, all coordinates will be exchanged. So this is the coordinate with a point with the coordinate 4 and 1. Its reflection will be here at 1 and 4, and this is the point with the coordinates 6 and 4, and its reflection will be 4 and 6. Let's call this the f inverse and call the original one f. Now these two functions have domains and range. Let's look at domain of f. Domain of f is this stretch of numbers. Let me write it down. This is 0.4, this is 0.6. Range of f inverse is this range of numbers from 4 again to 6. So this is domain of f. This is range of f inverse. Obviously they are the same. So let's write that. Domain of f is same as range of f inverse. Similarly, if we go ahead and look at range of f, Here's a range of f that goes from 1 to 4. And here's a domain of f inverse. That's again from 1 to 4. What we get from this observation is that domain of f inverse is same as range of f. Another observation that's easy to see on this picture is that slope of f and f inverse are obviously connected. If you look at f, the rise of this is 3 and the run of it is 2. That's right. From here to here is 3 and here the run is 2. For f inverse, these numbers are reversed. The run is 3 and the rise is 2. So the slope of f inverse is 2/3, slope of f is 3/2. These slopes are reciprocal, so slope of f inverse is 1 over slope of f. Okay, one final and major issue is the existence of inverse function. So here we are going to talk about existence. Question is, does every function have an inverse? And the answer is simply no, for a certain technicality that's easy to see. Let's take this example. Function y is equal to f of x is equal to x squared. Let's make a table for this. Here's my table of x and y values. Suppose I have 0, y becomes 1, x is 1, y becomes, excuse me, if x is 1, y is 1, if x is 2, y is 4, and so on. Now suppose I give you output 9 and I ask you what's the input. You could say the input is 3, but you could also say it's minus 3. Either way, when you square it, you get 9. So between plus 3 and minus 3, which one is the correct answer? Well, the problem is that both of them are correct, and because of a technicality of the function that requires just one single answer, we say y equal to x squared does not have an inverse. So here let me write this one does not have an inverse. Why? Because if you start at 9, you don't know where to go back. That's a problem at 4 also. 4 relates to both plus and minus 2. This 1 relates to both plus and minus 1. But 0 relates to just 0, but that doesn't help the situation because you have all these choices in all these other points. Let's go ahead and graph this function and see it in a picture. What's going wrong here? Here is the graph of y equal to x squared. It's just a simple basic parabola. So it comes down and goes back up. So if you have an output here like 9 or 4 or any of these numbers, what are you supposed to do to find the input? Well, suppose this is 9. You could go here and find that input is supposed to be 3 down here, but you could also go this way and find out that the input was minus 3 on this other side. So this horizontal line cuts the graph in 2 places, and that's responsible for giving you 2 possible answers, and that's where the difficulty is. So this brings us to horizontal line test. Excuse me. Let me write that again. I have horizontal line test. It says if any horizontal line cuts a graph at more than one point, then the corresponding function of that graph does not have an inverse. Okay, that concludes our short review of inverse functions, and now we are going to apply this to a list of functions we are going to look at, exponential functions, trigonometric functions, and others. We go ahead and review the lectures. Make sure you understand the basic points before you start doing your exercises. Good luck and God bless.